Salam and greetings. My name is Muhammad Aiman bin Muhammad Ruslan, matrix number KIB1004. Today we will be conducting an experiment regarding Thevenin and Norton circuit. We will be testing the Thevenin theory for simplified circuit using the simple circuits with resistors and DC power source. For the first circuit, we have the schematics and the values for the four resistors on the right side. We have R1 98.6 ohm, R2 327 ohm, R3 500 ohm, and R4 997 ohm with a Vs of 5 volts. We will run the DC analysis with table of DC results. Firstly, we must obtain the value of IR4 and VR4. The value of VR4, which is 2.44 volts, and the value of IR4, 0.0024 ampere or 2.4 milliampere. We will then log in the values into the table in Excel. And then we will replace R4 with an open circuit of VM to measure the potential difference at the open circuit VM across terminal AB. Again, the value of VM as we obtained from the DC analysis is 3.84 volts. We will then log that value into the table. And then we will replace the open circuit with ammeter to measure the short circuit current across terminal AB. The value we obtain, which is IM, will be 0.00667 ampere or 6.67 milliampere. Now this experiment will show that from the obtained Thevenin equivalent circuit, the theoretical values will approximate to the matching components. Matching the components. IM will be approximate to ISC, which is current short circuit. The VM will be approximate to VTH. And by calculating IR4 using the calculated values and comparing it to the measured IR4, this will hereby prove the theory. Now, for the calculations, we have RTH, which is simplifying R1, R2, and R3 into a single resistance without R4. VTH is the voltage difference across terminal AB without R4, and ISC, which is the current going across terminal AB where R4 is removed. So then we will be calculating the values here by using the formulas on the right. And then we will be comparing them to see how close they approximate each other. As you can see, the values that have been calculated using the formulas and the values that are being measured are very close to approximating each other. VM and VTH. Next, we'll move to the second circuit, circuit number 2. Again, we will use another circuit to prove this theory by using parallel circuits with 5 resistors. R1 to R4, we will be using the same values, but with R5, 150 ohms, with same DC supplied voltage of 5 volts. We will then run again the DC analysis with the table of DC results. The value that we want to observe here is the value IR4 and VR4. the value of IR4 being 0.00226 ampere or 2.26 milliampere, and the value of VR4 2.26 volts. We will log in the values into the table in Excel. Next, we will be replacing R4 with an open circuit VM at terminal AB to measure the potential difference. We will observe the value of VM, which is 2.69 volts. We will then log the value into the table. And then we will be replacing VM with an ammeter to measure the short circuit current IM across the terminal AB. The value IM here we observe will be 0.01406 ampere or 14.06 milliampere. The theory is the same for this circuit where the theoretical values will approximate to the matching components. IM approximate to ISC, VM will be approximate to VTH, and by calculating IR4 using the formula and comparing it to the measured value, we will be proving the theory. For calculations, RTH will be simplifying R1, R2, and R5 into a single resistance without R4. For VTH, which is the voltage difference across the terminal AB without R4, and then for ISC, the current short circuit across terminal AB without R4. Now for VTH, we have to calculate VTH-A and VTH-B, as there is two complete loops across the in the circuit. So by calculating VTH-A, which is 3.84 volts, and VTH-B, which is 1.15 volts, we will be able to, using the formula again, we will be able to calculate VTH. And then we will be measuring, we will be calculating ISC, which is the short circuit current. As you can see, it approximates to the measured value of IM, which is using the ammeter across the terminal AB of 14.617 milliampere, compared to IM, which is at 14.06 milliampere. And then we'll be calculating IR4 to prove the theory and see its accuracy. So as you can see, the calculated value of IR4 is 2.2621 milliampere, whereas the measured value will be 2.26 milliampere. When calculated all the values from circuit 1 and circuit 2 between the measured and the calculated values, the difference between the values are roughly about 1%, which shows the values calculated and measured are very accurate to confirm this theory. So that is all for me. Thank you, and this concludes our experiment for today.